Okay, in this video, we're going to work some example problems where we integrate rational functions, rational expressions, using partial fraction decomposition. So, okay, we want to integrate this rational function. The first step is, we go back to what we learned in algebra. We want to perform partial fraction decomposition on the integrand. So, how do you do partial fraction decomposition? Well, first step is you check to see is the we have a rational expression here, polynomial in the numerator, polynomial in the denominator. First step is you check to see is the order of the numerator greater than or equal to the order of the denominator. In this case, it is. So since it is, we need to start by doing polynomial long division. Okay. All right, x to the fourth divided by x is x cubed. X cubed times the divisor, you've got x to the fourth minus x cubed. Subtract these. Okay, 0 plus 1, so that's just x cubed plus 0x squared. X cubed divided by x is x squared. Multiply x squared times the divisor. You get x cubed minus x squared. Subtract these two. 0 plus 1, so that's x squared. Okay, x squared divided by x is x. Multiply x by the divisor. X squared minus x. Subtract these two. 0x plus 1x, so it's x plus 0. Okay, x divided by x is 1. Multiply 1 times the divisor. So you've got x minus 1. Subtract these two. Positive 1. Okay, so we can rewrite this integral as the integral of, so x cubed plus x squared plus x plus 1. Okay, then plus, we've got 1 over x minus 1 dx. Okay, so we see that we have this integral is equal to, so 1/4 x to the fourth plus 1/3 x cubed plus 1/2 x squared plus x plus the integral. Okay, so now what is this integral here? Well, this is an easy one. This is just the natural log of the absolute value of x minus 1, right? Don't forget the absolute value. But you take, you have the derivative of natural log of absolute value of x minus 1 is 1 over x minus 1 times the derivative of x minus 1 is just 1. So okay, now don't forget the constant, and there we go. Okay, so we've got a rational function here, and it's already the denominator is already factored for us, which is nice. So we want to do the partial fraction decomposition. Polynomial in the numerator, polynomial in the denominator. First step, check is the order of the numerator greater than or equal to the order of the denominator. In this case, it's not. The order of the denominator is 2. The order of the numerator is 1. Okay. Next step is you factor the denominator, fully factor it. Here it's already factored, so we can go to the next step. The next step is you write the decomposition, the form of the decomposition. So we've got two linear factors, both to the first power. So there's the decomposition of the first factor, and then there's the second linear factor. So that's the form of the decomposition. Now we want to solve for A and B. So clear, next step is you clear the fractions, multiply by the least common denominator. So we've got 5x plus 1 is equal to okay. Now there's two ways you could go about solving this for A and B. You could distribute this and combine the x squared, x to the first, etc. terms together and then match that up with the left side. Or you could just choose a value of x and use that to solve for A and B. So that method is usually pretty easy, but sometimes it just depends. I feel like I feel like the more complicated these get, then it can then become easier to go ahead and group the common order terms together. But okay, let's set x equal to 1. And so that makes so okay, 5 times 1 is 5 plus 1. The a term goes away, and we've got 2 times 1 is 2. Okay, so 6 is equal to 3b. So b is equal to 2. So we've got b is equal to 2. Now if we set x equal to minus 1/2, you get minus 5/2 plus 1 is equal to, oh wait, oh no, that's right, okay, yeah, is equal to, so a and then minus 1/2 minus 1. So minus 5/2 plus 2 over 2 is minus 3/2, and then a, okay, so a is equal to, you got minus 3/2 and then divided by minus 3/2, so minus 2 over 3, which is equal to 1. So a is equal to 1. Okay, so we can rewrite this as the integral, so 1 over 2x plus 1, and then plus 2 over x minus 1 dx. Okay, so we've got, and then plus, let's take out the 2 here. Okay, so this integral is easy. We just did this integral, so this is going to be 2 times the natural log of the absolute value of x minus 1. Here, all you need to do is just make a u substitution. Say u is equal to 2x plus 1. Or if you think about it, you could do this in your head. So if we have the natural log of the absolute value of 2x plus 1, right? So we take that derivative, we get 1 over 2x plus 1, and then times the derivative of this, which is 2. So we need to get rid of that 2, so you just put a 1/2, right? And then this, there we go, plus c. Okay, here, this is a definite integral of a rational expression, but same process. We're just going to go ahead and integrate this, but instead of ending with the indefinite integral, we'll evaluate it from 0 to 1. So, okay, rational expression. Let's do a decomposition. So first, check is the order of the numerator less than the order of the denominator. It is. Like, this is technically a polynomial, right? This is 2x to the 0. A 0-order polynomial. So the order is less than the denominator. So next step is we want to factor the denominator. So, okay, we've got a quadratic trinomial with leading coefficient not equal to 1. So we do. So 2 times 1 is 2. And So then 2 times 1 gets 2 plus 1 is positive 3. So we can rewrite this as we want to group. Let's group the 2x with the 2. Okay, so we haven't changed this expression, right? So now let's do grouping. So with these two terms, we'll factor out a 2x, and that's x plus 1, and then plus x plus 1. So now let's factor out an x plus 1, and you've got, so there we go. X plus 1 times 2x plus 1. So okay. So now let's write the form of the decomposition. Right, we have two linear factors, both to the first power. So this is the full form of the decomposition. So now let's clear the fractions. So we've got 2 is equal to a times 2x plus 1 plus b times x plus 1. Okay, let's set x equal to minus 1. So we've got 2 is equal to minus 2 plus 1. A times minus 2 plus 1. So minus 2 plus 1 is minus 1. So minus a is equal to 2. A is equal to minus 2. Okay. Now let's set x equal to minus 1/2. So we've got 2 is equal to b times minus 1/2 plus 1. So 2 is equal to b times 1/2. So 1/2 b is equal to 2. Multiply both sides by 2. You get b is equal to 4. So, okay, this is the definite integral from 0 to 1. Okay, so we've got 2x plus 1. Okay, and then dx. Okay, so let's take out the 4 here, then 1 to 0. Okay, let's take out the 2 here from 0 to 1. Okay, so this is 1/2 natural log of absolute value of 2x plus 1. So 1/2 times 4 is 2. So 2, we can bring the 2 out, and we've got natural log of the absolute value of 2x plus 1, and we want to evaluate this from 0 to 1. Okay, and then here, it's just the natural log of the absolute value of x plus 1. Evaluate this from 0 to 1. Okay, so, all right, 2 times, okay, you plug in 1, you get natural log of 3. We can remove the absolute value. You plug in 0, you get just natural log of 1, which is 0. Okay, now minus 2. Okay, here you plug in 1, you get natural log of 2, you can remove the absolute value, and then you plug in 0, you get natural log of 1, natural log of 1 is 0. Okay, so 2 natural log of 3 minus 2 natural log of 2. So we can look to simplify this a little bit more. We can bring the 2 into the inside of the natural log. So we have 3 squared, so natural log of 9 minus 2 natural log of 2 is natural log of 4. And we can write this as, so, you know, it's personal preference, however you want to write it. I mean, we could, this is 3 over 2 squared, right? So we could take out the 2 and it doesn't matter. You can write it however you want. So I'll just put it like that. There we go. Okay, so we need to integrate this rational function. So to perform partial fraction decomposition, let's first see if the order of the numerator is less than the order of the denominator. It's not in this case, so we need to do polynomial long division. Okay, x cubed divided by x squared is x. Now multiply x by the divisor. Subtract these two expressions. So we've got 3x squared and then minus 4x minus 2x. Okay, 3x squared divided by x squared is 3. 3 times the divisor. Okay, minus 6x plus 9x, 3x, 1 minus 6. Okay, so we've got x plus 3 plus, and then okay. So now we want to perform partial fraction decomposition on this rational function. So okay, so the degree of the numerator is less than the degree of the denominator. So next step is to factor the denominator. So we've got okay. Okay, so now we want to write the form of the decomposition. We've got two linear factors raised to the first power. That's the form. So now let's clear the fractions, multiply by the least common denominator. Okay, so we've got 3x is equal to okay, so now if we say x is equal to 1, then you've got minus 2 is equal to minus b. B is equal to 2. If you say x is equal to 2, you've got 6 minus 5. Okay, a is equal to 1. Okay. So that is the decomposition. And so we have the integral is x plus 3 plus that's the integral, right? We put this here. Okay, so let's see. We've got 1/2 x squared plus 3x plus natural log of the absolute value of x minus 2 plus 2 times natural log of the absolute value of x minus 1. Okay, all of this evaluated from minus 1 to 0. Okay, plugging in 0, we get natural log of the absolute value of minus 2 plus 2 natural log of the absolute value of minus 1. Okay, all of this minus, now plugging in minus 1, you've got 1/2 minus 3 plus natural log of the absolute value of minus 1 minus 2 plus 2 times natural log of the absolute value of minus 2. There we go. Okay, so natural log of 2, natural log of 1 is 0, minus 1/2 minus 3 plus natural log of 3 plus 2. Wait, no. Minus 1/2 plus 3 minus natural log of 3 minus 2 natural log of 2. Minus 1/2 plus 3 is minus 1/2 plus 6/2. So 5/2. Natural log of 2 minus 2 natural log of 2 is minus natural log of 2 plus 5/2 minus natural log of 3. So we've got 5/2, or no. Yeah, no, that's right. Minus natural log of 2 minus natural log of 3. Okay, so the degree of the numerator is less than the degree of the denominator. The degree of the denominator is going to be 3. All right, so let's do the partial fraction decomposition. It looks like it's already factored for us, the denominator. So, okay, and we've got 3 linear factors to the raised to the first power. Okay, so now we want to clear the fractions. So y plus 2, y minus 3. So we've got 4y squared minus 7y minus 12 is equal to plus b, it could be by plus c y. There we go. Okay. No, wait. No, this would be y plus 2. Okay, when y is equal to 0, we've got minus 12 is equal to a times 2 times minus 3 minus 6a is equal to minus 12. A is equal to 2. All right. When y is equal to 3, we've got 9 times 4 is 36. 7 times 3 is 21. Okay, so 3c times 5. So 36 minus 21 is 15. 15 minus 12 is 3. C is equal to 1/5. Okay, now when y is equal to minus 2, you've got 2 times 2 equals 4 plus 14. Okay, minus 2b times minus 5. 16 plus 2 is 18 is equal to 10b. b is equal to 18 divided by 10 is equal to 9/5. All right, so we've got okay. So what we've got is the integral, take out the 2, okay, plus, and then okay, so 2 natural log of the absolute value of y evaluated from 1 to 2 plus okay, so 2 natural log of 2 minus natural log of 1 is 0 plus 9/5 natural log of 4 minus natural log of 3 plus 1/5 natural log of 2 minus, okay, so that's 0, then minus natural log of 1 minus 3, 2. All right, so we've got 2 natural log of 2 plus, so natural log of 4 is natural log of 2 squared. We could bring that 2 out to the front. So we've got 18/5 natural log of 2 minus 9/5 natural log of 3 minus 1/5 natural log of 2. 18/5 minus 1/5 is 17/5. 2 plus 17/5 is, so 10/5 plus 17/5 is 27/5. So 27/5 natural log of 2 minus 9/5 natural log of 3. And that's the integral. Okay, let's do partial fraction decomposition. We can see the degree of the numerator is less than the degree of the denominator. The degree of the denominator is 4. So we've got okay, it's the denominator is already factored, and we've got just 2 linear factors, but 1 is raised to the power 2. So we do, the form is that's the form. So now let's solve for A, B, and C. Okay, so we've got x squared plus x plus 1, and then so A times x plus 1 plus B plus C. Okay, so when x is equal to minus 1, you've got 1 minus 1 plus 1. Okay, so b times minus 1 plus 2, so b is equal to 1. Okay, when x is equal to minus 2, you've got 4 minus 2 plus 1 minus 1 is 3. Okay, then minus 2 plus 1 is minus 1 squared. So c is equal to 3. Okay, now when x is equal to 0, we've got 1 is equal to 2a, and then 2 times b, and then c plus c. 2a is equal to 4a is equal to 2. Okay, so B is 1, C is 3. There we go. Okay, so we've got the integral from 0 to 1 of okay, and so this is 2 natural log of the absolute value of x plus 1. Well, no, let's do this. Let's go ahead and separate this. Okay, so now this integral here, we solve using, any linear factors, no matter what they are, we can solve using a u substitution. So u is x plus 1 squared, du is dx. So when x is equal to 0, u is equal to 1. When x is equal to 1, u is equal to 2. So we've got minus u to the minus 1, evaluated from 1 to 2. So minus 2 to the minus 1, so minus 1 half, minus 1. Minus 1 half plus 1, 1 half, okay? So this is 1 half. So we've got, now let's do, so this is 2 natural log of the absolute value of x plus 1. So 2 natural log of 2 minus natural log of 1, so 2 natural log of 2. Two natural log of 2. So now we want to do, so we've got, this is going from 0 to 1. So we've got 3 times natural log of 3 minus natural log of 2. 3 natural log of 3 minus, okay. So 3 natural log of 3 minus natural log of 2. All right. 2 natural log of 2 plus 1 half plus 3 natural log of 3 minus 3 natural log of 2. 2 natural log of 2 minus 3 natural log of 2, so minus natural log of 2 plus 1 half plus 3 natural log of 3. So 3 natural log of 3 minus natural log of 2 plus 1 half. Okay, and I messed this up. The a should have been a minus 2. I'm not sure. If you go back and look, I might have just copied it wrong, or I missed it. I think I just copied it wrong. So we have this. This would be minus 2 natural log of 2. And so we've got minus 2 natural log of 2 here. And so this is minus 2 natural log of 2 minus 3 natural log of 2 is minus 5 natural log of 2. So we've got 1 half plus 3 natural log of 3 minus 5 natural log of 2. And again, I'm not sure. I erased what I had, but I either I had this as a as a -2 and just copied it here wrong, or I might have messed up forgot to carry a minus sign somewhere. But you get the idea.